Hi, we are going to talk about something called infinite limits. So here's a function we're going to look at, f of x equals 2 over x minus 2. And for that function, hopefully you can recognize that in this function you can't use 2 as the value of x because you're going to end up dividing by 0. But as we know with the concept of limit, we can see what's going to happen as you approach 2 from left and from the right. So here's a table of values that we completed, and I already have the values computed for that. So when the value of x is 1.5, that's going to end up giving you negative 4. For this value you are going to get negative 20. And for this value you're going to get negative 200. So you can see as I get closer and closer to 2 from the left, my values are getting smaller and smaller and smaller. I'm talking about in the sense of negative values. If you continue doing this, you're going to start getting values that are even smaller. But what happens on the other side? So here we are going to get 4, here we're going to get 20, and here we're going to get 200. So on this side, on the right hand side, this function is increasing. So what we say here, as we approach 2 from the left, f of x is decreasing without bounds, which means it's going to continue getting smaller and smaller and smaller. And we can recognize this limit here because it's becoming negative. It's going to be negative infinity. And as we approach 2 from the right, our function f of x is going to be increasing without bounds. And we can write that limit as positive infinity. Okay? So, the concept of limits, of infinite limits that we're discussing right now, if you recall from your Algebra 2 course or pre-calculus course where you discussed rational functions that are usually a very typical example. So what happens is that concept of vertical asymptotes is very closely related to infinite limits. That's precisely what happens. This function, let me show you this again, is going to have a vertical asymptote at x equals 2. And that's why this is going on. Okay? So, one thing that you do need to know is that the limit of this function at 2 is not going to exist, because for limit to exist we need finite values. We cannot operate with infinities. Okay, but if you have a situation where a vertical asymptote or a function has a vertical asymptote, that means you are going to have a positive or negative infinity as a limit on one side. So let's analyze this function. This is 3 over x plus 1 squared. So as we are going to, well, first of all, it's x plus 1 squared on the bottom, so it's always going to be a positive value on the bottom. As we're going to start getting closer and closer to negative 1 from the left, this number here is going to be x plus 1 is going to be getting smaller and smaller. Now we're going to square it. Now we're going to divide 3 by that really small number. We're going to get a very large number, and that number is going to be positive. So in this case, this one-sided limit is going to be infinity. Okay? And if you use the same logic for the right-hand side, you approach negative 1 from the right, you are going to end up getting the same exact thing. It's also going to give you infinity. So I don't want you to just assume that every time you have an asymptote, one side is going to go up, one side is going to go down. You should have seen plenty of examples in your previous math classes where they both on both sides of a vertical asymptote the graph can go up or down. But that here, even though they both go to infinity, you still do not have a limit at x equals negative 1, because you need to have finite values. Alright? So here is one other function that we're going to look at. But basically what happens every time you're going to have some kind of a rational form, and if you get what we're trying to establish here is, as you are going to look at the function and try to evaluate limits as you approach one number from right side or left side, how do you know you are going to have a vertical asymptote, which will in turn will help you determine what's going to happen with the with the limit. So what you know is, if you try to substitute a value that you have into the function, and you're going to have non-zero value on top divided by 0 on the bottom, that will give you infinity, either positive infinity or negative infinity. So that's how you would know. All right, and that's basically what we're going to go by. So here's another function here. You can probably recognize that this function is going to have two vertical asymptotes. One's at positive 2, one's at negative 2. Because at both positive and negative 2, you are going to get non-zero on top divided by 0 on the bottom. A situation with 0 divided by 0 is for another lesson, which I already have in my channel. So here we are going to approach negative 2 from the left. So what's going to happen here, if you plug in negative 2 from the left, the top is going to be positive, right? This is how you can figure out what's going to happen. Because one way you can do it is with the graph, but that's not always something you can do. So if I'm doing here, I'm going to write this on the side. So the top is going to give me positive. Because I'm going to have non-zero divided by 0, I know it's going to be infinity. It's just a question is which one, positive or negative. What am I getting on the bottom? So I take a number a little bit less than negative 2. Let's say negative 2.1. If I square that, that's going to be slightly greater than 4. Right? So it's going to be slightly greater than 4 minus 4. So it's positive also. So it's positive over positive. We already established that, because when you substitute negative 2 into this function, you are going to get non-zero divided by 0. That means you are going to have infinity, one or the other. So positive over positive is positive. So we're going to get positive infinity, or simply infinity. So what's going to happen when you approach this value of negative 2 from the right? So when you approach it from the right, the top is still positive, but the bottom, so let's see, let's close to negative 2, let's say negative 1.9. When you square that, you are going to get a number slightly less than 4. So slightly less than 4 minus 4 will give me a negative value, right? So positive over negative, that's negative infinity. So if you continue with the same logic, let's see what's going to happen here. 2 from the left. So 2 from the 2 from the left, like 1.9 squared is a little bit less than 4. So negative on the bottom, and the top is still positive, so that's going to give you negative infinity as well. And then when you do this, apply the same logic, you're going to end up getting positive infinity here. Okay? And I'm just going to show you really quickly what the graph of this function looks like, so you can kind of see what it is. So here we go. So if this is the left side of negative 2, you go to infinity. That's this. This is the right side of negative 2, you go down to negative infinity, it's heading down. This is the left side of positive 2, negative infinity also, and this is the right side of positive 2, which is positive infinity. Okay. Alright, so one last thing that I want to mention here is, do they all have to be in some kind of rational form? The answer is no, they don't. There are functions that are going to be, some kind of other functions, not necessarily written as anything in the rational form, yet they can still have asymptotes. Certain trig functions, tangent, cotangent, secant, and cosecant are all going to have some asymptotes. So it's a little bit trickier here trying to do this analytically, but if you remember the graph of tangent, tangent is sine over cosine. So it consists of a bunch of branches that go like this. Okay? So, but the important thing here is, since it's a sine of x over cosine of x, whenever cosine is going to be 0, as long as the sine is not 0, like for example at pi over 2, you are going to get the non-zero divided by 0, which indicates an asymptote. And as you can see, this is actually pi over 2. Okay, so it's helpful to know what the shape of that graph is to make your life easier. So what we can see here is, so this is the left side of pi over 2. So on the left side of pi over 2, it's going to go to infinity. And on the right side of negative 2, it's going to go down to negative infinity. Now, you can do this without graphing that, so you can do it analytically, but I mean, not analytical, numerically, you just gonna need to pick some numbers close to pi over 2 from left side and right side, and you just want to see what sign you're getting, but it's a little challenging to do this without a calculator here. Okay, but it could be done. Another example here, it should be example 4, my apologies. What about cosecant? So cosecant of x, what does that graph look like? Just want to remind, it's one of those functions that you don't see a lot. This is what those graphs look like. It's a bunch of shapes like this. These are the axes that you're going to get. Cosecant is 1 over sine. So whenever sine equals 0, obviously the numerator is not a 0 value ever, you are going to get a vertical asymptote. So what do we have here? We're approaching 0 from the, so one of those values where sine is 0 is 0, obviously. So when you approach 0 from the left, that's this side here, this is going to head down, so it's going to give us negative infinity. Okay. And on the other side, as you approach 0 from the right, it's going up, so you're going to have positive infinity. And this is how it works. Any questions, post them, and I hope this helps.